Hi, everyone. I will go over some housekeeping items for the webinar as we get people in. Just to let you know, hopefully you're in the right place. This is the Vernier Just Breathe, Measuring Lung Volumes to Understand Lung Function webinar with John Melville and Sarah, who will be introducing themselves in a moment. I'd like to tell you, or I'm going to be launching a poll, and if you could fill out the questions, that would be awesome. We're just curious to see what you're wanting to cover in the webinar today, if it's more just the lab itself, or if you're interested in more details about the graphical analysis that will be shown. We just are curious for that. So I'm going to launch it now. If you don't mind filling it out, that would be awesome. We are willing and able and want to answer your questions during the session today. So feel free to either use the chat or the QA function. We'll be monitoring both of those. And if we happen to not get to your question, we will follow up with you afterwards to get those answered. In a few moments, I will be sharing some additional resources. So I'll provide a link in the chat to the shared folder where you can find those details. And just let you know, we are recording this session today and it will be available on our website. And I'll put the link to where to exactly find that in the chat later on towards the end of the webinar. And just let you know, you also get a follow-up email with the webinar recording link, the link to the shared additional resources folder, and a certificate of attendance. So let's see. So John and Sarah, it looks like 100% high school and 100% want to know more about the lab itself.
Great. That's terrific.
If you want to go to the agenda slide, I will go over the details there. So in just a moment, John and Sarah will be introducing themselves. John will be showing you the lung volumes and capacities experiment from our human physiology experiments, volume 2. He'll go over some of the details of graphical analysis as part of the experiment. We'll do Q&A, and then towards the end, we'll give you a reminder of where you can find the recording. So with that, I will pass it over to John and Sarah.
Hi, my name is John Melville. I'm the director of the biology department. I'm also a biology staff scientist here at Vernier. I got my bachelor's degree in biology and psychology at Sonoma State University. And then I got my PhD in zoology at Oregon State University with the focus. I taught a lot of human physiology courses there. I was a teaching assistant there. Then I did a postdoc at the University of Oregon. But what I always like to say is the most important thing, though, is that I'm a former educator. So I taught at a small liberal arts college called Wartburg College, and then I also taught at a community college called Lane Community College. And I have a lot of background in majors and non-majors courses in biology, teaching human physiology, neuroscience, marine physiology, etc., but with a primary focus on active learning with an emphasis on data collection and inquiry. And I also used to work with lots and lots of pre-service teachers. When I was at Wartburg College, we worked with lots of pre-service teachers. And then I will let Sarah introduce herself.
Hi, I'm Sarah Talarvik. I got my bachelor's degree at Northern Arizona University in Flagstaff, Arizona, and I did my PhD at Oregon State. It's in zoology. I did a postdoc in neuroscience at UT Austin. And then I worked actually as a professor for 15 years, also at a liberal arts college, teaching everything from freshman level biology courses to anatomy and physiology, as well as courses in neurobiology, animal behavior, vertebrate physiology, vertebrate zoology, you name it. So I have a lot of training as a behavioral physiologist. And I also worked extensively with science education and was very involved with K through 12 level outreach activities. So I'm also a fan of active learning, hands-on experimentation with students in the lab, inquiry-led exercises, and that definitely guides a lot of my work with Vernier.
So just to remind you for this webinar, we're here for you. ask all your questions in QA. And someone will be answering your questions there as we go. I'm not going to answer them. Sarah will let me know if there are questions there, and we'll say, hey, John, hey, we have a question for you, but you should feel free to ask questions there. At the end, if time allows, we'll discuss questions at the end of the talk. What would be really great, because you don't have to have, you do not have to have a device with you to see data. I'm going to try to send data wirelessly to you today. You might want to look at getting graphical analysis right now on your device. You can go to our website and you can download graphical analysis for Mac or PC on our website. If you search for graphical analysis, you can also get it in the Chrome Web Store or the Android Store or iOS Store if you have those devices. And we'll be able to send you data that you can analyze with us. So just download it if you don't already have it. And also, if you do already have it, make sure you update it to the latest version, which is 5.12. And for this demonstration, no sensors are required. One thing that I wanted to talk about is we're going to do a live demonstration, but I want to talk to you about how to do this lab activity. You're just studying lung volumes. And I've got a GoDirect Spirometer, but I would like to know how many of you have this old one? Like, for those of you that are here, tell me whether you have the new one or the old one, because it's not a big deal for me to switch in. I can show you how to do both of these, use both of them in graphical analysis. So if you want me to talk about how to use the old one and the new one, we can totally do that in this webinar, even though I'm going to focus on the new one more. But the keys to how to do the lab accurately are all the same. It all involves really sitting quietly and not moving too much while you breathe. Just so you know, this lab activity is taken from our Human Physiology Experiments, Volume 2. And Sarah is one of the she's the lead author on that book. And we made a bunch of improvements to this lab activity actually in that book, specifically around the math. And that's really what I want to focus on, is we've made the math, I think, simpler and easier to understand, because you can actually just measure different like vital capacity and tidal volume. And it's just going to be easier for you to get the other features that you need from this lab. So the two key things with this activity are, one, the math, simplifying the math, and then two, the technique. And the technique is actually what's kind of critical. So just remember, Vernier is for teachers by teachers. I am going to do a Graphical Analysis Pro live demo with you later, but I want to focus on the GoDirect Spirometer. That's this little device here. And it's great. It's just our wireless version. Well, actually, it's both. This one has to use an interface. You have to plug this one into a LabQuest Mini or a LabQuest or some other device. It has that white cable that you're probably used to right here. The GoDirect sensors don't need an interface. They can connect wirelessly versus via Bluetooth, or they all have at the tip here a USB port. So you can connect them directly to your computer, or you can use them wirelessly. The really cool thing I like about this little device, the little GoDirect Spirometer, is not only can it measure tidal volume and other lung parameters, you can use it to analyze lung function. You can compare and analyze different respiratory parameters, but it has some pretty nice features on it. One of the things that a lot of teachers ask us all the time is, I've got some baseline drift. How do I get rid of that baseline drift? There's a special channel that you can turn on with the GoDirect Spirometer that gets rid of all of that. And I'll show you how to use that. We also have special channels for like long experiments, so that if you wanted to do like a really long experiment where you're breathing in and out and in and out, we have a way to just capture the tidal volume for each breath and calculate respiration rate. So there's a lot that it can actually do. All right, so for the lab itself, let me go back there a little bit. One of the things that you need to understand when you're doing this lab is you start by breathing in and then exhaling, and the students are supposed to breathe normally, and that's usually a big ask. So if you look at this graph right here, this is showing breathing in, breathing out, breathing in, breathing out. One normal breath in and out produces the tidal volume. So that's the tidal volume. Normal tidal volumes for most people is around half a liter. You just need to be aware that if you're doing this lab, don't be surprised if students have a tidal volume of around 1 liter or it's larger than normal. And that's because they're taking the spirometer, right? They're taking the spirometer and they're putting that in their mouth. And you're not going to breathe normally, or it's hard to breathe normally if you have a foreign object in your mouth. So don't be surprised or worried if tidal volumes are larger than they should be. That's normal. The other thing to be aware of is in this lab, what we're trying to look at is vital capacity. So what you normally do in this lab is you breathe normally in and out 3 or 4 times. Then you inhale as hard as you can, and then you exhale as hard as you can. And the difference there from the peak inhalation to the peak exhalation, that's vital capacity. So that's this big peak that you see here. Once you've calculated vital capacity and you have tidal volume, you can then go in and find your inspiratory reserve volume, which is basically just the difference in tidal volume and vital, and parts of this phase of vital capacity. And then we can go look at expiratory reserve volume. So that's really all that this lab is creating a graph that looks like this and then finding these values on the graph. All right, so I'm going to use graphical analysis to set this lab up. So I'm going to show you graphical analysis. I'm going to connect the device to software, and then I'm going to go through and do the actual experiment. And you'll probably be really happy pretty soon because I'm going to have to be quiet while I do the experiment. So I won't be able to talk while I'm doing it. So let me just go to graphical analysis. I'll bring it over here. This is graphical analysis. I'm going to stop right here for a minute. I'm going to increase the screen size so it's going to be easier for you to see. So over in the top right-hand corner, I'm going to select presentation mode. I'm going to scale that up a little bit for you. Now there's 2 ways to connect the spirometer. I could just plug it straight in over, I could plug it straight in right here. I could plug it straight in over USB and it would just be identified, which is really nice. Or I can connect it wirelessly, and that's what I'm going to do. So I'm going to just tap on this button. And you can see it's flashing red. That means it's broadcasting. That means it's sending out a signal that it can be picked up. And I'm just going to start a new experiment here so it'll look like what you would see if you were just starting. And I'm going to select sensor data collection. And it's going to show me all of the devices that are in the room that are turned on. And you can see right here, it says GDX SPR 11006. That's because each one of these has a unique identifier. And if you take a look at it, you look up really close, maybe that might be in focus. You might be able to see that number there. That is the proper number, 1006. What's nice though, is if you look here, there's this proximity connect. Proximity connect is really nice because I can just I can literally put this right over my computer right next to it. And I can select proximity connect and it's going to find it, see how it's found it, and then it's going to connect to it automatically. So that's a really useful tool to do with your students. Great, so now I'm connected. So now I'm connected wirelessly and I'm ready to do the experiment. Now, one of the things that I was going to show you before we do the experiment is I am going to just add that other channel that I told you about. We don't have it on by default, but you can turn it on if you want to. If you go down to the bottom right corner and select sensor setup, you'll see that there are these other features, sensor channels. And you can see that this device can measure pressure, it can measure cycle volume and respiration rate. I'm going to add adjusted volume. There we go. And then now we're all ready to do this experiment. It's going to show you flow rate and volume, and I've just added adjusted volume. And all that I'm going to do is I'm going to inhale and exhale normally 3 times. And then I'm gonna inhale and exhale as hard as I can once, and then return to normal breaths. Now, there's a few key things that you need to be aware of when you're using a spirometer, even if you're using the old one. Like everything would be the same so far, except that adjusted channel if I connected the old one too. It would show you flow rate, it would show you volume, and you could do the whole experiment that way as well. And I can repeat that for you if you're interested and show you the old. The big thing to remember is you definitely do need to use a bacterial filter, which is actually pretty good at filtering out viruses too. If you're interested in that information, I can get it for you. And you need to use a mouthpiece. Now, the mouthpiece is a key thing because you're putting your mouth. So you don't blow on this like a horn. You don't do that. It has to go in the mouth. Now, there is a natural mouthpiece from a different company that you can buy, this thermoplastic mouthpiece, that works really well, and you will get better data with it. Because the more naturally this fits in your mouth, the more naturally you're going to breathe. And see, this has this little thermoplastic mouthpiece. It can be cleaned, it can be sterilized. We just wind up sending you these right here because they're very affordable.
John, I have a question for you.
Sure.
Can you reuse those bacterial filters or share them?
You cannot share these bacterial filters. You quote unquote can reuse them, meaning one student can reuse them. The bacterial filters are designed to protect the spirometer from the student or subject, me, and the subject from the spirometer as you're blowing in and out of it. So you could reuse this as long as only one student used it. So if one student wrote their name on it, they could reuse it. I do know people that do that. They'll take this, put their name on it, put it in a plastic bag, and then it's the students and they use it when they're doing the experiment. But they cannot be shared. The reason why that's really important is, I have people that say, oh, well, we're only going to exhale out of them. And I would normally say, that's great, but you don't want to risk that. If you have another student that puts their mouth over this and exhales and then just inhales, they're going to expose themselves to whatever other person was breathing through it. So it's basically one per person. That's really important. The other really important thing to be aware of is both of these spirometers have something on them that says inlet. 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 That's the side you breathe on. So the bacterial filter wants to go on the side that says inlet. Same thing here for where it says inlet. It's nice and snug. And then I'm going to put the little mouthpiece on here. And then what I'm going to do is I am going to, the next thing that you would do is you want to make sure that you hold the spirometer in the position that it's going to be used and then zero it. That's like really critical. You want to make sure that you're holding it in the position that it's going to be used. And then you want to zero it, either one. So I'm going to go over here and I'm going to go to the flow rate and I'm going to zero it. And then now I'm ready to collect data. And the big thing is I don't want to move the spirometer back and forth, either one of them. I want to sit still while I'm breathing. So here, let me breathe. We'll see how the data comes across. Remember, 3 normal breaths, and then 1 big exhale, 1 big inhale, and then recovery breaths. There we go. So that right there in a nutshell is the key to the experiment. And then let's take a look at some data. So the top channel here is the flow rate, and the integral of the flow rate gives us volume. It's not really critical to look at the flow rate for the experiment. So I'm actually going to go up here under view options, and I'm just going to say show one graph. I hope that's okay. I'm going to say show one graph. And then what's really nice is the data is all here. It all still exists here. I'm just going to change this axis. I'm going to just show volume here first. So there's the experiment here, and we can take a look at these volumes. I'm breathing a little bit more unnaturally than maybe you would imagine. Like I said, I've got a foreign object in my mouth, but let's say we want to calculate tidal volumes. To calculate tidal volume, all that you really need to do is measure from trough to peak. So if you have this value and you know that value, you know that the first one is 0.96 liters, that's one tidal volume. The second tidal volume, that's 0.09. Subtract that from 0.108, that's about 1, right? If I go over here, once again, that's 0.05, go up to 1.25, you subtract those two from each other and you get the tidal volume. There's a simpler way to do that as well, which is you can just highlight the region there, go from peak to trough, go down to the bottom left corner under Graph Tools and say View Stats. And it's going to give you the delta Y. And the delta Y is that difference between what you've measured, the base and the top there. So that's 0.96 for the first tidal volume. Could do the same thing here, go through and say View Statistics. 0.993 for the second tidal volume. For the next one, that's a little bit bigger, 1.2 liters for the third tidal volume. And you could take an average of those to find out what that is. All right, what about any questions on that so far? One of the things that's neat is if you turn on that other adjusted volume channel, I'll show that to you. It corrects for that baseline shift. So you can see right here, the blue line is the adjusted volume. Let me show you that. Actually, that's actually pretty nice here. Let me turn this on here. Graph Legend. There. So that you can see on this graph. So to get to the Graph Legend, I just went to the bottom left corner, tapped on Graph Tools, and then turned on the Graph Legend. And you can see it's going to show you the greenish yellow color is the straight up volume, and the blue is the adjusted volume. If they're on top of each other, it's going to default to yellow. So that's 0.94. And if you wanted to, I could change these colors. Let me tap here. I'm going to tap here and I'm going to change that to red for you. There we go. So you can see that the first tidal volume, it starts at about 0. First tidal volume is about 0.96. The blue is also 0.96. If you look right here, if I go to the blue line there, remember it has this drop here. So it recognizes when it's in a trough and then subtracts off right there and finds and subtracts it. So that's the baseline drift. So once again, 0.99. Once again here, you can see about, 0.12. So it's the adjusted volume channel is actually doing that calculation for you in most cases. Any other questions? I'm just going to show you how to get vital capacity next.
John, we did have a question, and that is, what is the average tidal volume for a teenage student? 1 liter seems a little high.
1 liter does seem high. Tidal volumes they are all going to depend on the individual. Tidal volume fluctuates with an individual's size. Normally, it would be about ½ a liter. Like I said, the issue is you're putting this foreign object in your mouth and you're reflexively going to breathe more than normal. It takes practice. If I were to use this thermoplastic mouthpiece, it would be smaller. The example that I usually like to use is I'm a former scuba diver. And they would always tell us when we put the octopus, the regulator in our mouth, hey, breathe normally and you'll be fine. You're not going to breathe normally with something in your mouth that has an increase in resistance. You're going to reflexively breathe deeper. And that's why you see an increase in tidal volume. But the average tidal volume for most just individuals, and this is normally college-age men that they give these numbers for, is about ½ a liter. So I'm breathing quite a bit more here than you would normally expect. That isn't a big deal for getting the idea behind this lab. You could have someone just practice breathing and you will see that they will breathe in a more normal way.
Thank you.
The other factor is, what about vital capacity? So let me turn off the adjusted volume channel. Well, vital capacity is just the difference between the peak of the inspiration, because remember, this is inspiration going up, going positive, and exhalation is negative. So 0.25, 0.245, and then the difference is about 0.84. If I get the magnitude of that, will actually give me vital capacity. And this is one of the big differences in this new lab, is if you go through the write-up in the lab, we have you do this. It used to be that we would have you estimate IRV and ERV. So you would go along and you would see like, well, it looks like the tidal volume's about here. So, you know, sort of estimate what the IRV would be, the inspiratory reserve volume, which would be all the way to this peak. And then you would go through and you would sort of guesstimate or estimate, well, what's the inspiratory reserve? And what Sarah and I realized is it's just easier to get the mean tidal volume and then go and get the vital capacity. If you just select from peak to trough, and then once again do a few statistics, there the delta Y is 3.287 liters. So that's vital capacity. Once again, I could turn on the adjusted volume channel and it should be about the same here. Yeah, 3.287. All right, and then, I mean, you could look at the recovery volumes here too, the tidal volumes too. You can see that the first recovery breath is bigger, and then these recovery breaths are probably larger than they would normally be on average. That's about ½ a liter. Or they're back up to normal. A little bit higher, but those are recovery breaths. So questions on that so far? I mean, what you normally would, go ahead.
What's typical for vital capacity?
It really varies. It's around that, they like to float around 4 liters is what most people would say. But remember, vital capacity, it doesn't fluctuate a tremendous amount, but it's going to be different for women and men, where the average male 20-year-old typically around 4 liters. But the bigger you are, the bigger that number will be. So it does fluctuate.
Thank you.
If you wanted to calculate IRV, the inspiratory reserve, what I would do is that you could go here and you could say, well, what's the average tidal volume? It's probably somewhere between, you know, 1 and 1.2, maybe 1.1. Hey, look at that. There's 1.1. If you look at the difference here for 1.8 and the peak here, 2.45, if you get the difference between those, you know, that'll give you the inspiratory reserve. Or you could look at the mean and then calculate that. Or you could just say, well, you know, I'm going to take this last data point here and look at that data point there, and I'm going to like calculate that. But that's how you would actually calculate or measure the inspiratory reserve, is look at right around where the tidal volume is. And you could say, well, it's right around 1 liter for me right there. And then find the difference here in the peak. So if we were to guesstimate that it's about 1 liter, and you know my peak here was 2.42, then my inspiratory reserve is about 1.42. And then what I would do is I would calculate expiratory reserve. So let's go back and take a look at that. So let me minimize this for a minute. Right, and can you all see this? Can you see down below here, is there something in the way? You see, you can calculate ERV by just taking vital capacity, taking inspiratory reserve, right? So here's inspiratory reserve, add tidal volume, and then you know you're going to take vital capacity and subtract that from it, and that's going to give you ERV, this portion down here. And then I believe in the lab we estimate that residual volume, because you can't measure it, but your residual volume in the lungs is about, I think it's about ½ a liter, but all of that's in the lab instructions. A lot of these factors and things that are really interesting would be in the teacher's notes. And so if you buy the book, there's teacher's instructions, which gives you a lot of these key hints and other features and things that would be good to know. Questions so far? I'm going to take this data and send it out to you next, is what I thought we would do, if that sounds okay. But other questions on how to do the actual laboratory exercise or questions?
John, in terms of the positioning for the student, you mentioned to not tip it back and forth. Do you recommend doing something like resting the elbows on the table and holding it level?
Resting the elbows on the table is always really good. Oh, pardon me there. So like if you, hold on, you'll let you see this here. So if you rest the elbows on the table like this, while you're holding it, that's really good. The same thing goes for the old spirometer. So if you have the old spirometer, by the way, the bacterial filter fits on it as well in the same way. If you rest your elbows on the table and hold it at mouth level, that's really good. And the key thing is you want to zero it in the position that it's going to be used. The number one factor that we see with students when you get bad data typically is they zero it when it's on the bench. That's right, they've got everything set up right here. They go to calibrate, they go to zero the flow rate, and then they pick it up. And these are differential flow sensors that are in these. So they're really, really sensitive to changes in position. And that's why you'll see data that like floats up or floats down. So it's really important that you zero and then breathe in the proper position. It's also really tough to get a really strong exhale and inhale without pulling yourself back and then throwing yourself forward. And that's an important thing, is you don't want to do that. You don't want to have the students, throw their neck back to breathe in and then forcefully throw themselves forward to breathe out. You'll get problems that way too.
All right, and we do have another question. What's the purpose of the final breaths after the big exhale? Since those values ended up below baseline, what can you use them for besides tidal volume?
Oh, well, they're there just so that you can see recovery. What's really, really interesting is if you were to do this, if you were to do a breath hold, which is another experiment that we do. Let's say you were doing a breath hold. So you have the students breathe normally, breathe normally, breathe normally, and then hold their breath for as long as they can. Right. And then start breathing again. What you would wind up seeing is recovery breaths. So you'll see that tidal volume gets much, much bigger as you're recovering, and then it gets normal. It's really just to see that after you do a big inhale and exhale, you do recover. What you will normally see is that first recovery breath that the student takes after they have exhaled, after they've inhaled as hard as they can and exhaled as hard as they can, will typically be larger than the standard tidal volume, and then it will begin to get more normal. There's nothing to say that you can't do more breaths for this activity. You could increase the duration of the experiment and have them do like 10 normal breaths. And then, one big inhalation and one big exhalation, and then 10 normal breaths. So you could still look at tidal volume. It's to show you that your body, the whole concept of homeostasis, once you've exhaled as hard as you can and inhaled and then exhaled or held your breath, your body's going to want to return to homeostasis. So you're going to have recovery breaths that are probably going to be bigger than normal. And then as your whole system is getting back to normal, it's going to recover, and your respiratory rate, your tidal volumes are going to return to normal at rest. It's the same thing that you would see like with after exercise or things like that, is if as soon as you stop exercising, you're going to have these recovery breaths, tidal volume is going to be bigger. And then as your heart rate goes down and you begin to recover, they're going to be much more normal. Great question. Other questions? All right, so what I wanted to try to do next is let's I want to send you some data, or I could do the same lab. I could show you the same lab. Why don't we do that? Let me show you the same exact lab. Well, does anybody here have the old spirometer? Like, is anybody interested in seeing how the old spirometer works? If you don't say yes in the Q&A, I'm going to skip it.
I haven't seen an answer pop up yet.
It's effectively the same. You just don't select that adjusted volume channel. There's no channels to select, but everything else is the same. You just plug it into the the interface. So you would plug it into your LabQuest Mini for interface, plug that into your computer. If you just launch it, it's going to be all set up. And then you would just do everything the same. The issue is you do not have access to that adjusted volume channel, and there is no way to control for baseline drift like there is in Logger Pro. So it's really important that you hold it, that you zero it and hold it directly upright. One thing that I used to tell a lot of teachers before is it's not critical if that baseline is drifting. The data looks ugly, but it's not critical as long as you're measuring from peak to trough or trough to peak. You'll be able to measure tidal volumes accurately. You'll be able to measure VC. You'll be able to get an indication of IRV and ERV, even if it's drifting a little bit. It doesn't have to be perfectly level for you to get good data. The data just looks nicer. All right. So what I'm going to do next is what I want to do is I wanted to show you how data can be shared over the internet. This is a great feature of what we call Graphical Analysis Pro. So I'm going to take that data that I generated and I'm going to start a session. And then I'm going to show you how you could send this to your students wirelessly. Before I do that, does anybody have any other questions about how to export data or things like that? Maybe I should just show you that really quick. I'm going to go back to GA anyway.
Yeah, John, would you show how students can export graphs and export or save their data?
Yeah, so one of the key things is you can save this data. So you could save it by going up here to where it says Untitled. You can save. So I could save this as, see this PC. Yep. So I don't want to save to documents though. I want to save it to, here we go, desktop. Spirometer test. Now that the data has been saved. One of the important things, I'm going to disconnect the spirometer because we don't need it right now. So I'm just going to disconnect it. So this is actually really important to know if you're using them wirelessly is they'll stay connected. So then you can see the little green light flashing. So I'm going to hold down for 5 seconds on this little button and it'll disconnect it because we're not going to need to collect data with it right now. And it'll say, Bluetooth connection, but the data is still here. If I want to export this data, I just do the same thing. I go to the top, click, and I can select export. And then I can choose how I want to export it. I can export it as a graph. And I can save that as a PNG. I could save it as a PDF. CSV, that's the comma separated values. That's the format that you would normally use for like Google Sheets or Excel. And then this feature here, AMDL, this is our legacy file type for if you wanted to bring it into our other software. So if you want to save that, you could save that and then drop that into Google Docs. That's how you could save the graph. There are other ways to annotate it. So if you wanted students to annotate it, you could say add annotation. You could write in tidal volume and you can insert many annotations. And then when you go to export the graph, you'll see that those are actually on there. It's going to move these around a little bit, but you can go to the graph shape and you can change it. And then that will move them around. And then you can always go back and move them so it's clearer when you have those annotations there. You can change the line shading, darker, lighter, etc. All right. So any other questions before I move along? It's really simple to change between these values by just interacting with the y-axis. I could turn on flow rate if I wanted to, or just a volume. you just toggle these. Once again, if you wanted to see how to change the color, I just tap on this icon right here and I can change the color. Right, so what I'm going to do
John,
next.
Was that a
yes.
feature of, that was a feature of regular GA or GA Pro?
Color changing?
Yes.
I believe that's normal. I'm not in GA Pro right now. So, right, everything that I'm doing right now, it says activate to use online data sharing. Everything that I'm doing right now, you can do in the normal version of GA.
That's great, thank you.
Yeah, so I can change colors. I can, see, I think I can do an integral if I wanted to. So those are key basic features that you do not have to be turned on. And the same thing goes for if, so yeah, for everything I'm doing right now, I am not using the Pro version. What I'm going to do next is I'm going to activate the Pro version. So I'm going to go here to about, and I'm going to type in a code to activate it. And this is the same thing that you would do if you wanted to activate GA Pro, and you can do that. Let me exit out of here for a minute, and I can show you the code that you need to use. So the code that you need to use is this code right here. Oh, let me go back. This is all lowercase, TRO F12 capital VAB. So what you can do is if you type in TRO F12 VAB and hit submit, you now have access to GA Pro. And so you can go ahead and do that if you want to right now. You can have access to GA Pro. And this is actually what you would tell your students to do. If you bought a version of GA Pro, you would have them activate it just like I did, only it wouldn't say that it would expire in 11 days.
So this code for our participants, this code is usable for the next 12 days?
Yeah, about 11 days, yes, 12 days.
And you can also sign up for a free trial that's 30 days.
Yes. So one of the cool things about this is if I go up here where it says data sharing, I can then send this data to you. So what I'm going to do is I'm going to turn on data sharing. So I imagine that I've done an experiment, I've collected data, and I want to send this data to all the students in my classroom, or maybe I even have a bunch of students that are working remotely from home, or maybe we're under quarantine and my whole class is at home. As long as they have an internet connection and they're using GA Pro, I can send data to them. So I would then tap here under data sharing, and I would say start session. And then the important thing here is this number, QRJ5VP. Students, they're going to need to access to that. I'm going to make that bigger. And so then if I was a student, what I would do here, why don't I change this up a little bit so you can see this here. Let me go to the next page here, the student view and teacher view. So here's the teacher view. The teacher has said, hey, I've started a data sharing session. I want you to launch, GA Pro, and I want you to put in this code. So I'm just going to show you what that's going to look like on a Chromebook. So I'm going to switch to a Chromebook view, bring it in here. So the students, let me move the Chromebook over. Oh. So now I'm a student here, and I have a Chromebook. And I'm just going to launch GA Pro. So I'm going to start off with new experiment. When they launch GA Pro, instead of selecting sensor data collection, the students would actually select data sharing. And then it's going to say, hey, do you want to do local or online? Oh, I think I need to activate my GA Pro code. Let me see here. Yep, I need to activate it. So once again, I'm going to go over here and I'm going to activate it about. So I'm going to put in that same code. TROF12 VAB. Submit. There we go. And then here's the teacher view once again. Here's the student view. Great. And now I also have GA Pro now, so it's been activated. Let me increase the presentation size once again, so this is going to be easier for you to see. There we go. So the student would go up here and select new experiment, or they would just launch GA Pro to see and get a new. And then when they launch, instead of saying sensor data collection, they would choose data sharing. They choose data sharing, and then this is where they put in that number where it says enter the source ID, since it's defaulting to online. If we tap over here, we know that that number is QRJ5BP. QRJ5BP. Connect. And the data has come across. So I have sent the data wirelessly from one computer to another computer. And I've done this over the internet. So if you wanted to do the same thing right now, or if you have questions, I would just go ahead and do it. And this data will be sent directly to you. What's really nice about this is you can see that this graph does not have any of the annotations or anything else on it. So it just sends the data. See how on here I have these annotations put up, tidal volume, vital capacity, I have that turned on. None of that is turned on when that is sent across the internet. That means that each instance is its own. So a student could go through here and say, no, you know what, I want to make my graph blue instead, or I'm going to label it differently. They can do that. So it's a way to send data wirelessly. It's a really useful feature. Other questions?
No questions at the moment in the Q&A or the chat.
Great. And they could save it independently as well. So let me minimize that, and I'll minimize graphical analysis, or actually, yeah, minimize it for now. Oh, no, I don't want to do that. Fine.
John, is there enough time to show any of the other features of the spirometer, such as doing something like a flow loop? I don't know if participants are interested in flow loops.
I could do that. There is some really cool features associated with flow loops. I also can show them how to insert video. So what I would do is, for the participants that are here, would you rather see more features about the spirometer, or would you rather see more features about GA Pro? Because like a really nice feature as well is you can insert video with the experiment as well. But I can also show you more advanced features with the spirometer itself. But we have time. We have like 10 minutes, so I could do either or, depending on what people are interested in.
We had flow loop, please, from one of our participants.
Flow loops are interesting. We don't save this. So let me go back to graphical analysis. Then I have to remember how to do a flow loop. That's going to be the settings to do a flow loop. So let me launch graphical analysis here again. So I'm going to connect this spirometer, turn it on. Let's connect to the spirometer. Now, let me just do you what you would normally think of as a flow loop, and then I'll talk to you about how you have to change it. Basically, a flow loop is you're going to be looking at flow and volume simultaneously. It becomes a loop. So if I were to hit collect and then inhale and exhale as hard as I can. If I were then to go to and just show one graph, and then what I could do here is go down to the bottom and show flow rate as a function of volume. This is what we're trying to show is this flow loop. That's how you would normally do a flow loop. The thing is you want the flow loop to close. And that's usually what's really hard is you want the flow loop to close as you're breathing. But one of the super really nice things about our book, so let me go and show that to you here really quick. That would actually be a nice feature. We have some time here is we have specific instructions for how to do that with this spirometer in our lab book. And so let me go back to here.
And that's in the 10th lab in the book. So it's Human Physiology Experiments, Volume 2, Lab 10, Lung Function.
Yes, and what I wanted to show you as well is that we have this really nice sample data library. So if you wanted to take a look at it, if you were to go to the sample data library, searching for sample data library. If I go to the experiment sample data library, if you were to browse the library, what's really nice, I think it's really nice that it defaults to biology first. It's a really great thing about it being alphabetical, but if you scroll down, you'll see we have almost all of the experiments for Human Physiology Volume 1 and Human Physiology Experiments Volume 2. And we actually have the data and the write-up right here, so you can take a look at it. So if you were to tap here, these are the lab instructions for it, like how to set up the spirometer properly. And then I also have the sample data that we got for it as well right here. So if you're interested in doing a flow loop, getting it to work well, the instructions are right here, as are the sample data if you want to show your students. One of the other really cool things was if you were to buy the book, you could download the book contents. They're all in Word format. You can easily switch the word contents to Google. So let's just download this here. Yeah, I think it's going to automatically upload. It's going to give us access to it in the Google Doc. There we go. So if you're going to change it, the thing that you need to do when you're using the spirometer is you need to change the volume inspiratory polarity to negative. Let me show you where that is.
Yeah, that's
So
kind of a hidden feature that's in the advanced options.
Yeah, so if I go back here, so I've got the spirometer connected. What you would do is you tap down here in the bottom right corner where it says sensor setup. And then this little icon right here where there's this eye for information, you want to tap there. And then you would go to advanced. And that's where you would switch it to negative. Other questions? There's some really, really cool features here in the advanced features. So if you wanted to recalibrate the spirometer, there's a way to do that using the volume correction factor. There's a bunch of other features that you can use to look at cycle volume. We even have some data that's in the spirometer, so you could change it to demo version, and then you can play that data into GA if you wanted to in real time. If you're interested in any more features or advanced features with spirometry, or I would say human physiology, I would recommend just emailing Sarah or I at biology@vernier.com and just asking for either of us. We're the two physiologists that have the most experience with this. So
John,
other questions?
we have a question in the chat asking, Jonathan's results have negative lung volume. I'm guessing that that's in reference to the flow loop.
Did you say my results? Yeah, that's because the flow loop is backwards and you need to go in and you would need to change the inspiratory reserve. You would need to flip it to get good data. So other questions? Got about 4 minutes. Just remember, you can always get in touch with us. You can call us. You can email support. We have chat. But if you specifically want to talk to a physiologist, you just email biology@vernier.com. And one of us will get in touch with you. Other Q&A questions?
I don't think so.
Is anybody from Project Lead the Way in this webinar? The Project Lead the Way just recently switched from using our old spirometer to our new spirometer. They work pretty well. Either one does. Yeah, let's see. I think. Oh, so someone did have. You would change. No, you change the polarity before you collect data. What I was trying to show you is when you do the flow loops, most people are just going to connect it, do the experiment, and they're going to get data that's backwards. If you read the instructions for the flow loop, what you do first is you set everything up, you connect the device, you go into that special channel that I showed you, the special, and you change the polarity. And then that will give you the positive flow loop. That's the key thing to get it to work, is you have to be able to do that, or the flow loops are going to be backwards. Now, there is a way to correct for that. You know, if it's negative, you just make it positive because you know it should have been positive and you ought to be fine. But it isn't ideal. So that's why you need to go in there and change that. But those instructions that I just showed you right there, they're free right now. And so is the sample data. So I would encourage you to take a look at it. You can look at the experiment. You can see if it works for you, and you can test it out. There isn't a way to do that though with the old spirometer. So there is not a way to change the to make it the volume positive to negative. There is a way to correct for that. You could use a calculated column. If you're interested in doing that, get in touch because I can show you how to do that as well. GA Pro and just normal GA has some really cool features where you can take a column and you can multiply it by a factor so you can correct for that. So if you do have issues with your older sensors or want to do something special, just get in touch and we can try to show you ways to figure it out. Other questions? All right.
There was a question of X-1. It's in the Q&A.
Times -1 to fix numbers. Hold on.
Yeah, I'm not sure.
That's okay. Michelle, just get in touch and we can sort it out specifically. Just email, just email me or Sarah if it's a numbering thing or whatever it needs to be. Oh yeah, multiply by -1, you could fix it correct. Yeah. Yeah, exactly. If you wanted to fix the volumes, you could multiply by -1. You could do that in a calculated column, which is not hard to do. In fact, I wonder if I could just show you really quickly.
We're almost out of time.
Yeah, anyway, it's not that hard to do. I can show you how to do it. You just create a new calculated column. You would take that volume channel and you could multiply it by -1 and you would then make it positive. All right. Well, that's all we have for you today, unless you have other questions. So thank you so much for joining.